Hi guys, welcome again to Simplified RSA. The guys who makes it looks easy. I'm Mr. Maimane, and today we'll be looking at mathematics. Our selected topic for today, it will be sequence and series. And the question that we'll be looking at today is going to be this question here. Yeah. So this question is one of the questions that was selected by a student from one of the previous question papers. And without wasting time, let's go straight to the question. The question reads, the first term of a geometric series is 14, and the sixth term is 448. And then 2.1.1, they want us to calculate the value of the constant ratio R. Now, constant ratio R, other textbook may refer to constant ratio as common ratio. So it's the ratio that determines the how the sequence is going to be like for a geometric sequence. Now, under sequence and series so far, there are two things students need to remember. The first thing is we have arithmetic sequence, we have geometric sequence. Well, we have harmonic sequence, but then for students who are like now furthering their studies to university level and stuff, but then for a mere high school students, we just look at arithmetic and geometric sequence. Now, putting this image here, it will determine how the arithmetic sequence and geometric sequence look as well as the formulas. So you always have this. But then mind you, if you're writing an exam for a high school student, a formula sheet is always provided at the back of the question paper that has formulas which you know which formula to use. But then before you get to the formula or before you get to the choice of the formula which you should use, one needs to understand exactly what the module is all about so you can be able to tackle or you can be able to have a better selection of your equations, because all you need to do is just to accumulate some marks, right? So now, going back to our question, the first term of a geometric series is 14 and the sixth term is 448. And now you have this image here that I put here. You understand that arithmetic sequence is like this, geometric sequence is like this, meaning now since we are dealing with geometric sequence, we are here on this one, the below one. So now, the first statement, when they say the first term of a geometric series is 14 and the sixth term is 448, what do they mean? This is what they mean. Now, in our understanding, we always know that a sequence is always a case where we have the first term, the second term, the third term, up until probably the nth term, right? Some book can denote this as A, A1, A2, A3, up to AN. Well, you can find a classroom mathematics textbook showing this as T1, first term, second term, third term, up until the nth term. This notation, that's what we understand. This is what determines what a sequence is. So in this case, this is what we have. So in this case, this is what we have. The first term is 14. We don't know what the second term is. We don't know what the third term is. We don't know what the fourth term is. We don't know what the fifth term is. But according to the statement, they're saying the sixth term is 448. So this is what they mean. So the first term is 14 and the sixth term is 448. So we know that T6 is equals to 448. And we know that A, which is our first term, because according to sequence and series, A is always the first term. And we always refer to the first term as A, like that. So this is what we have. So now that we understand the first line of the question, now how do we approach to calculate the constant ratio R? In a perfect world, it is far much easier to determine the constant ratio, which is the common ratio, if you understand the actual sequence, if you know the values of the sequence. But then in this case, we only know the first term and we know the sixth term. But then with that information, it is enough for us to can calculate what they need. Let's look at it like this. So this is our first term A, this is A1, this is A2, this is A3, this is A4, this is A5, and this is A6, right? So far, we know that AN is equals to ARN minus 1. We know this from this table here. This is the formula that we have. So meaning that A6 A6 is going to be, I know the value of A, the first one is 14, the first term is 14. And then it's going to be 14 R n minus 1, n minus 1, 6. N is 6, n minus 1, n minus 1, then n 6 minus 1 is going to be 5. So I have this here. And from here, I do know that A6 is 4, 4, 8. Therefore, 4, 4, 8 is equals to 14 R to the exponent 5. Now, solving the value for R here, I would have calculated my common ratio, which is my constant ratio. Let's calculate it here. So from here, moving forward, I'm just going to divide by 14 both sides. So I will have R to the exponent 5 being equals to 32. This is when I've divided by 14 both sides here. So this will cancel that, and then 448 divided by 14 is 32. And then to solve this, I just remove the exponent there, multiply by 1 over 5, this multiply by 1 over 5, therefore R will be 2. So meaning our common ratio is 2. So this is the answer for 2.1.1. This is how we answer 2.1.1. So as you can see with this one, it doesn't look that much challenging because all you needed to remember was just the nth term under geometric sequence. And then with the information that we had, we just had to determine the value of the common ratio R. So on 2.1.2, we are asked to determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Remember, we're already given the first 6 terms now, and we know the common ratio now, meaning we can determine the first 6 terms now. But then besides that, they just want to know how many terms must be added from the 6 that we already know in order to obtain a sum of 114,674. This question can be tricky, but then let's break it down together. Think of it as you have 6 terms already. They want to know from the 6 that you have, how many more must be added for you to achieve that sum of 114,674. I think it's easier when we scribble it down. Let's break it together. So for 2.1.2, we already know that the sum of a series under geometric sequence, the equation is given like this, right? Now, they want us to determine what is the nth term for us to obtain the sum of 114,674. So it's easier to work it out as, let's first get the nth term for that sum of 114,674, and then we're going to determine the difference with the 6th term to get the actual value for us, to get the actual value of what they want us to calculate. So we're going to work it like this. So we want to get the nth term for obtaining 114,674 in total, because we already know the value of the first term, which is 14. It was given the common ratio R. We calculated this one on the previous question and we found it to be 2. And then now we just need to determine the value of n there. If you simplify this, 2 minus 1 is just going to be 1. So here we'll have this. And here you can see I can simplify further by dividing by 14 both sides. This will cancel that, and then 2n minus 1 will equal . And as you can see, 2n minus 1, this one you can take the 1 to the other side, and then we'll get 2n is equals to 8192. To solve here, we're going to use logarithm to solve this one. Therefore, n is going to be log of 8192 92. If you don't understand what I've done here, there's a video where we explain logarithm as well. Therefore, the value of n will be, if I punch this on the calculator, I will get 13. Now, this is where the trick is. You may think 13 is the actual value that you have to calculate. No, 13 is the term that obtains 114,674 from the first term. So first term, second term, third term, fourth term, and then you go up to the 13th term. That's when you get that value. But then the question, they wanted to know how many, they wanted to know the number of consecutive terms that must be added from the first 6 that were given to us in order to get to the 13th term. So from 6, what is the difference between 13 and 6? You know what I mean? That's what this is what they mean actually. So to finally answer 2.1.2, the question, they wanted us to determine from the 6 terms that they're already given to us, how many must we add in order to achieve the 13th term, whereby the 13th term is the one that obtains 114,674 when all the terms are added together. So to get this, you just take the 6 to the other side of the equal sign. So it's going to be 13 minus 6. So our actual answer is 7 terms. So from 6 terms, they have to add 7 more terms in order to get to the 13th term that obtains the sum of 114,674. Okay, this may seem a little challenging, but then we know that with practice, it becomes easier and easier and easier, and then we just need to practice more. Also, it is advisable to always summarize stuff. Like for instance, if you look at this table here, it breaks down the summary of what to expect in terms of sequence and series, and then understanding this, it can help you tackle a lot of questions. Let's look at the next one, 2.1.3. It reads the first term of another series. Okay, sharp. Now it's a different one now. If the first term of another series is 4, 4, 8, and the 6th term is 14, they want us to calculate the sum to infinity of the series, of the new series. And again, looking at this table here, we can see that the sequence to infinity is actually just that formula there. We just have to determine the common ratio R again. And now from 2.1.1, yes, from 2.1.1, we can tell like now how are we going to go about in order to determine the letter R, which is our common ratio. And then we know the first term is given is 448. And then that's it, because the formula looks like this. But then otherwise, let's put it down on the board. So there is no complication with the sum to infinity. This is what the formula looks like. And we already given the first term, which is the value of our A. We know that A is 448 this time around. But they didn't give us the value of R. But however, they gave us A6. A6 is 14. A6 is 14, but then we know that AN is equals to ARN minus 1 under geometric sequence, because the sum to infinity still falls under geometric sequence. So meaning from this, we can determine the value of R there and then just substitute and get the value. And then to get that, we're going to use A6 again. We know that A6 is equals to ARN minus 1, and n minus 1 is 6, 6 minus 1 is 5. So A6 is going to be AR to the exponent 5, and the value of A is 448 R to the exponent 5. Simplifying this one further, we divide by 448 both sides because we want to solve for R. We're going to get R5 to be 1 over 32. 1 over 32. And then simplifying this one further, we'll get R to be 1 over 2. So our value of R there is 1 over 2. So if R is 1 over 2 and A, so let me just put it here. Now we know that A is 448 and we know that R is 1/2 because we calculated R here. And then all we need to do is just to substitute. So sum to infinity is going to be 448 divided by 1 minus 1/2. And if you punch this in your calculator, your final answer will be 896. That means the sum to infinity will be 896. So that's it. That's how you answer this question paper. If you have more questions, feel free to send us an email. Here's our contact details here. You can send us either an email, WhatsApp message. You can DM us on our social media platforms. And please subscribe to our YouTube channel so we can get more efforts to keep on pushing such content. And also just follow us on any social media platform that you may come across under the handle simplified_RSA. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. Join us on our next video as we simplify more things.